Draw the graph of 2y plus 5x plus 8 equals 0. Okay, well, we've done examples where they simply told us the intercepts, or one of the intercepts and the slope. And we've had questions where they gave us an equation in what we called slope-intercept form, where it looked like y equals mx plus b. And we like that form because from it we can pick off the slope immediately and the y-intercept immediately. Those numbers are obtainable by inspection if you have slope-intercept form. This is not slope-intercept form, and so we have a bit of a problem. There are two ways that we can graph this line, and I'll show you both of them. The first one is to take this expression and turn it into slope-intercept form. And the second one is to find the two intercepts, which it turns out is not all that hard to do when the expression's in this form. So let's start by getting slope-intercept form. We'll see how that goes. Slope-intercept form simply is an equation for a line where you have y equals everything else. So if we're starting with 2y, I'll just copy this out again, 2y plus 5x plus 8 equals 0, we must manipulate this so that the y is isolated on the left. That means we need to subtract 5x and 8 to get them over to the right-hand side. We can do that quickly enough. 2y equals minus 5x minus 8. You might think of this as simply move these to the right-hand side, and when you do, their signs change. That's fine, that works too. Next, if I want y to be isolated, we have to get rid of this multiplication by 2. So if we divide the whole works by 2, we get y equals minus 5 over 2x minus 4. That is slope-intercept form. And this is exactly what we need if we're going to sketch this line, because this tells us the slope is minus 5 over 2. We'll need that in a moment. And it tells us that the y-intercept is minus 4. And that takes all the difficulty out of this question. We've done practice like this before. Y-intercept of minus 4 means we cross the y-axis at 1, 2, 3, 4 units below the origin. A slope of minus 5 over 2, oh, this might be a little tricky, means we have to go down 5 units and 2 units right. So 1, 2, 3, now I get to eyeball, which I'm not delighted about. 2 units right. Should end up about there. And you could get a straight edge and connect those two dots and be reasonably confident, but it doesn't feel all that good to be going 2 units off the grid and having to try to do this freehand. Is there another way we could use this slope? Yeah, there is. We pretty much always tell you when you're writing fractions that if there's a negative, either put it out front or put it in the numerator, and that is a standard that we do typically follow. But in this case, we can reinterpret this slope. Minus 5 over 2 is actually equivalent to 5 over minus 2. Right? The fraction's negative either way. But this helps us here because if we think of the rise over run as 5 over negative 2, it means from your starting point, you could go 5 units up and 2 units left. And if we do that, 1, 2, 3, 4, 5 units up, 2 units left, good news, we've got all kinds of space over this direction, and we can map that exactly. I might even be able to do it again. 1, 2, 3, 4, 5, 1, 2. That's much better. I trust those points more than the ones that I had to eyeball down here. So if you need a precise graph, remember that little trick that you don't have to leave your negative in the numerator. Sometimes putting it in the denominator like this gives you a friendlier slope to work with. Fair enough? All right, so that was the method of turn it into slope-intercept form, which works just fine. Let's try another way. The other way I mentioned was get intercepts. Given this equation, 2y plus 5x plus 8 equals 0, you can always find the x-intercept of an expression by subbing in y equals 0, and you can always find the y-intercept of an expression by subbing in x equals 0. Well, we love intercepts because subbing in 0 is actually pretty easy. We can do that quickly. If y is 0, this expression becomes 2 times 0 plus 5x plus 8 equals 0. 5x plus 8 equals 0. X equals minus 8 over 5. I'm solving this a little bit fast because I assume you have experience with this. So we get an x-intercept of minus 1.6. For the y-intercept, we put in x equals 0. 2y plus 5 times 0 plus 8 equals 0. 2y plus 8 equals 0. 2y equals minus 8. Y equals minus 4. And then we could go plot those points. The x-intercept is minus 1.6, which would put it right about, yep, there. So if we were doing this by the intercept method, we would plot an intercept there. Now, plotting minus 1.6 is not the easiest thing in the world, but nevertheless, it's possible, and we could plot that point. And for the y-intercept, we get minus 1, 2, 3, 4, and look at that. We would have gotten the same line that way. In this case, the slope-intercept form was easier to plot because it was all whole numbers. The minus 1.6 is a bit of a problem, but this is a valid way to graph lines. These values are not always decimals, so you don't always have this to worry about. It's ideally you'll be comfortable with both ways, but by all means, try them both out and see which one you prefer.